Welcome to this introduction to Authorino. Authorino is a Kubernetes-native authorization service for zero trust, tailor-made API security. It is a lightweight external authorization server that implements the Envoy proxy external authorization gRPC protocol, and it is fully manageable via Kubernetes custom resources. If you're not familiar with Envoy proxy, I totally recommend checking out the things it can do for you. If you're not familiar with Kubernetes custom resources, I hope you are familiar with Kubernetes, and you can think of Kubernetes custom resource definitions, or CRDs, as a way to extend the Kubernetes API and to define new types of resources in Kubernetes, which you interact with as you normally would, just like any other resource in Kubernetes, such as a service, a deployment, a config map. And these custom resources are usually given meaning via a Kubernetes custom controller that acts on events related to the custom resources. You will be interested in Authorino if you are using Kubernetes, if you are using or looking into using Envoy proxy, and if you own an API that needs to do identity verification or token verification upon requests sent to the API, to enforce authorization rules or policies. Related to those things, Authorino also does some other very cool things, such as token normalization in case you have more than one trusted source of users or clients consuming your API, fetching of authorization metadata on the fly while protecting access to your API, as well as injecting data and or customizing responses based on authorization flow, and also caching of authentication authorization data. So how does it work? Here's an outline. An API developer builds an API. Let's call it the upstream API or upstream service. This service originally has no embedded concept of authentication or authorization, meaning it does not verify user passwords or access tokens via code. It does not have any logic implemented in the code that verifies access or permissions regarding, for example, particular endpoints or payloads requested by users of the API. The developer deploys this API behind an Envoy proxy facade. Next, the developer applies to a Kubernetes cluster running Authorino an AuthConfig Kubernetes custom resource. This custom resource states a recipe, so to speak, of identity verification and authorization steps to be enforced on every request sent to the protected API. For example, validate tokens expectedly issued by a no-auth 2 server or identity provider X. Enforce authorization rule Y, for instance, on post request to /admin/star, the user that holds a token must be bound to a row named admin. Let's call this user the API consumer for a more general term. So given that those rules have been stated, then the API consumer can obtain a token or secret to access the API and send HTTP requests to the API carrying that token. Envoy will intercept that request, establish fast gRPC connection with Authorino, and ask Authorino, hey, shall I send or redirect the request to this upstream API? Authorino will then look up for an AuthConfig recipe and enforce that AuthConfig for that particular request or payload. It will verify the token or secret that is bound to an identity. Eventually, it will go out and fetch additional authorization metadata from external sources, given that it's part of the recipe, enforce all the authorization rules and policies, build instructions to Envoy about data to inject in the request or custom response to the client if that is the case, and return to Envoy with either OK or not OK. If it is OK, Envoy redirects the traffic to the upstream service in a way that no traffic will ever reach the protected service if not properly authenticated and authorized by Authorino first. Then the upstream API can serve the request, passing through Envoy again to deliver the response to the consumer. You can use Authorino attached to a centralized API gateway, either an internal API gateway inside of your cluster or attached to an ingress. Authorino is a multi-tenant application, which means it can serve authorization for multiple unrelated APIs. Or you can use Authorino as a centralized authorization service with dedicated Envoy proxies deployed closer to each protected API, and all of them pointing to the same instance of Authorino. Or yet as a fully dedicated authorization service deployed as a sidecar, for example. It doesn't have to be a sidecar to be a dedicated service, but it can be if you want to. Hopefully it is more or less clear already what's the gist with Authorino. This seems to be a good moment then to say what Authorino is not. Well, Authorino is not a proxy. Envoy is a proxy. Authorino is not an identity provider, an IDP. It does not store any user information. It does not store user secrets. Authorino is not an OpenID Connect server. It is not an OAuth 2 client or an OAuth 2 server for that matter. Authorino is not an SSO server. Although if you are very experienced with Envoy and you know what you're doing, combined with Envoy, there might be ways to mimic a very simplified SSO server. Definitely, this is not Authorino's purpose. In its own, Authorino does not manage user sessions. It is not an SSO server. It can support SSO systems by extending the access token's reach to APIs, but it's not an SSO server. Authorino is not an identity broker for user authentication. It won't connect to you, say, with Google account or GitHub SSO. It won't handle authentication flow for you if your authentication service is an external IDP. It can verify tokens issued by those servers, given they implement supported protocols, but that is something else than brokering. Authorino is not a code library to be imported and compiled as part of an application. It is not an authorization data storage. In fact, it doesn't have a persistent state other than those AuthConfigs that the API developers apply to state the recipes for all they want. Authorino is not a rate limit service. Can you do rate limiting with Authorino standalone? Hardly. Should you do it? Definitely not. There are better proper solutions for that, such as Limitador, which I definitely recommend checking out. What we do have in Authorino are use cases of authenticated rate limit, nevertheless only using Authorino to set descriptors for an actual rate limiting service that is triggered post-authorization. If so far it sounded just like another authorization proxy, another authorization solution, please allow me to highlight why I think you should consider Authorino. Authorino gives you tailor-made API protection. It is whatever package of authentication authorization that suits your needs. Authorino provides all these building blocks for authentication and authorization that you can compose your very own AuthConfig recipe from. And it does that in a clean way, where by combining external authorization protocol and on-the-fly configurability, it doesn't involve changing your code, rebuilding your application when you want to add or modify your authorization layer. And Authorino is also cloud native, based on Kubernetes operator pattern, both for deploying instances of Authorino and at runtime for applying AuthConfig. It comes with all the benefits of a cloud-native application. It is scalable, resilient, stateless, manageable as code, fully automatable. And of course, Authorino is open source and based on open source technology and open source standards for Auth, including OAuth 2.0, OpenID Connect, Open Policy Agent (OPA), User Managed Access or UMA, amongst others. Here's an example of what you can do with Authorino. Let's say you have an API deployed to a Kubernetes cluster. If you want for another application, running the cluster to be able to consume your API, as long as there is a service exposing the API internally, the application can send requests to the service and the request will reach the API. However, there is no authentication or authorization going on here. If you want to protect the API, you can start by hiding the API behind an Envoy proxy facade. We rewire the service so Envoy handles all the requests before redirecting them to the API. Given that we have an instance of Authorino running in the cluster, we can define an AuthConfig to protect this API host and start identifying requests using, for example, Kubernetes service account tokens. The client application can use its service account token when sending requests to the API. Envoy will pass that to Authorino along with the external authorization payload. And Authorino will check whether the service account token is a valid token for this audience using the Kubernetes token review API. If we want to add some authorization, say, by leveraging the Kubernetes RBAC system for that, for example, given there is a role binding granting permission for that service account to consume endpoints of the API, Authorino will also check those permissions with the underlying authorization system of Kubernetes. Now, say we want to extend access to the API to external users that will consume the API using a CLI. We will probably have an ingress to handle the north-south traffic. We can add that host name to the AuthConfig and define an authentication method for those users. For example, we can use API keys to authenticate. It could be anything else. It could be MTLS, HMAC-based authentication, or anything. If an API key exists in the cluster bound for being used to consume this API, and the user has the API key, the user can then send the API key in the request to the API, and Authorino will verify if the key is valid. If we want to rate limit the request to this API using a rate limiting service such as Limitador, scoping the limits by username, for example, where each user can send no more than X requests per minute, we can add to the AuthConfig an instruction for Authorino to pass the username back as Envoy dynamic metadata. So Envoy can use that to set descriptors in the rate limiting service. This is already a relatively complex setup, one that will probably scale better by integrating an SSO server, especially now that we have external users. If we add a trusted OIDC server to the AuthConfig, Authorino will fetch the JSON web keys to validate access tokens issued by this auth server. So non-users of this SSO server can obtain tokens, JOTs, and use those JOTs to authenticate on request to the API. Authorino will then verify and validate the JOTs. Here's how an Authorino AuthConfig Kubernetes custom resource looks like, implementing all those things I have just mentioned. This is a fully functional AuthConfig with 2 host names for internal and external traffic, 3 authentication methods, authorization relying on Kubernetes RBAC, and generating data for authenticated rate limits. And here's another example of a different AuthConfig for a different use case, accepting access tokens issued by a Keycloak server and using Authorino JSON pattern matching authorization rules to check a JOT claim for a simple RBAC implementation using JOTs. These are just a couple examples to foster our creativity here. Of course, the list of use cases goes on and on. Authorino is very versatile. It offers a nice list of features, which I will not get into too much details here, but there are multiple interesting things to see, such as multiple authentication methods, fetching of all metadata from external sources, a powerful built-in open policy agent module for complex authorization policies written in regular language, caching, and plenty of other things. And the whole idea is to pick the ones that make sense for you, mix and combine them as you need. If you find it interesting and want to learn more about Authorino, check out our GitHub repo. There you will find tons of information, including detailed description of the architecture, documentation of all these features, getting started, hello world, and several other user guides with example-driven tutorials for various use cases. And of course, all you need to know in case you want to contribute to the project. I hope you have enjoyed. Thank you very much.